Hello, welcome to RVB Education. In this video lesson, we are going to find support reactions of the beam. This is a problem statement. We have a overhanging beam with a hinge support at A and inclined roller support at B. The beam is subjected to a point load and trapezoidal distributed load, which is a combination of UDL and UVL. The details of the beam are as given here. First, draw free body diagram of beam. But before that, we need to find the equivalent point load and its location. The beam is subjected to trapezoidal load starts at 20 kilonewton to 50 kilonewton per meter over a span of 6 meter. The trapezoidal load is split into UVL and UDL. A UDL is a base layer with constant intensity of 20 kilonewton, and the remaining triangular part on the top is its height is the difference between the two ends, that is 50 minus 20 is equal to 30 kilonewton per meter. Now we will going to calculate the equivalent loads. The equivalent load is equal to the area of load shape. This is a triangular shape, that is why 1/2 into base 6 meter into height 30 kilonewton. We get this 90 kilonewton. Next we are going to calculate for UDL. This is 20 into 6 is equal to 120 kilonewton. Now we are going to find the location of the equivalent load. This is centroid or location of UVL from the larger intensity side. This is the larger intensity side, which is at a distance of L by 3. We get 2 meter from the larger intensity side. And for UDL, the location is at distance of L by 2 from either side of the load, that is 3 meter. Now draw the free body diagram of beam. The supports are replaced by reactive forces due to the inclined roller support at B. An inclined reactive force is developed at the support. For easier calculation, this reaction force is resolved into horizontal and vertical component shown by dotted arrows. Similarly, the support reactions at hinge support A are also represented by a horizontal and vertical components with assumed directions. Then measure the perpendicular distance of each force from the point A and show it on the free body diagram for further calculations. And this is the complete free body diagram of beam. Now, using equations of equilibrium with proper sign convention, we solve step by step. First, the algebraic sum of all horizontal forces acting on the beam is 0. Using the chosen sign convention, rightward forces are considered positive and leftward forces considered as negative. By solving step by step, we obtain the following relation. The algebraic sum of all vertical forces acting on the beam is 0. Using the chosen sign convention, the all upward forces taken as positive and downward forces are taken as negative. By solving step by step, we obtain the following relation. To find the unknown force Rb, we take the sum of moment about point A. This is a sign convention we use for this. The line of action of reactive force Ra is passing through the point A. Hence, do not create a moment. The 120 kilonewton force acting downward at a distance of 5 meter from point A, which produce a clockwise moment about point A. The 90 kilonewton force acting downward at a distance of 6 meter from point A, which produce a clockwise moment about point A. Then the vertical component of reactive force Rb, which is Rbv, which is acts at a distance of 10 meter upward from point A, which produce anti-clockwise moment at point A. The 80 kilonewton force acting downward at a distance of 13 meter from point A, which produce a clockwise moment about point A. After solving all the steps, we get this answer 218 kilonewton, and by back substitution, we get RAV is equal to 72 kilonewton. The beam is supported by inclined roller support at B. Hence, we have inclined reactive force at A. In order to find the location of the resultant, we need to use reactive vertical component at B, 218 kilonewton. And we know the angle between the inclined reactive force and its a vertical component. By using this data, we can calculate the reactive force RB. Look at these steps. We get 251.72 kilonewton. The horizontal component of reactive force B. Just look at here, and we get 125.86 kilonewton. Hence, we have a reactive horizontal component at A and B is equal to 125.86 kilonewton. Next, we find the resultant force at A. And in order to do that, these are the complete state, and we also find the orientation with the horizontal. After solving, we get 29.77. We are shown diagrammatically. So these are the final support reactions, and with this, the problem is completed. Just take this problem for a practice and drop your answers in the comment box. I hope this video lesson helped you to understand the concept. Subscribe to my channel for more lessons. Thank you.